In this video, we're going to go through two more examples of solving a right triangle. So again, recall that for solving a right triangle, that means we want to find all missing side lengths and find all missing angles. So looking at number 1, I see that I am missing one side, my side BC, and I'm missing the angle measures of angle A and angle B. And so looking at this, remember whenever we're given two side lengths, to find that third side length, we can use our Pythagorean theorem. And so the Pythagorean theorem tells us that a squared plus b squared is equal to c squared, where my c is my hypotenuse. So I'm going to first label my hypotenuse in this right triangle. Well, I know the hypotenuse is opposite of my right angle, so that means that 25 is my hypotenuse. So plugging in all this information into this formula, I get 24 squared plus BC squared is equal to 25 squared. Well, 24 squared, I get 576 plus BC squared is equal to 25 squared, which is 625. Subtract 576 from both sides. And I get BC squared is equal to 625 minus 576, which is 49. And then taking the square root of both sides, I get that BC is equal to 7. So I'm a third of the way there. I found my missing side length. I see that BC here is equal to 7. And so I'm good there. Now I need to find my two missing angle measures. And so it doesn't matter which one you start with. I want to go ahead and just go with angle A. And here I really could choose any trig ratio that I want to, because I have all three that are whole numbers. There weren't any approximations when I solved for BC. However, I recommend just going with the ones that they're given to you. So I'm going to go with the 24 and 25. And so I already know 25 is my hypotenuse. 24 I see is right next to my angle A. So that means that this one is my adjacent. And so the trig ratio that uses adjacent and hypotenuse is my cos. So cosine is equal to adjacent over hypotenuse. And so I have cosine of A is equal to my adjacent, which is 24, over my hypotenuse, which is 25. And remember, when we're finding angle measures, we use our inverse trig ratios. And so I can take the inverse of cosine on both sides, and I get measure of angle A is equal to inverse cosine of 24 over 25. And so going over to Desmos, first do make sure that you are in degree mode. So click on that wrench and make sure degrees is highlighted. And then you can come here and we can go to functions, and I have all my inverse trig functions here. And then I'm going to click on 24 divided by 25. And rounding to the nearest tenth, I get that this is going to be approximately 16.3. And so I have measure of angle A. Last thing I find is my measure of angle B. And remember that measure of angle A and B are complementary, so that means that they add up to 90. So in other words, the measure of angle B is going to equal to 90 minus the measure of angle A. Well, measure of angle A we just found to be 16.3. And so that means that the measure of angle B is approximately 90 minus 16.3, which is 73.7 degrees. Okay, let's look at one last one. So here I want to find two sides and an angle measure. I am given one angle measure and one side. And so I want to start with finding my missing sides. It doesn't matter which one you start with. I want to go ahead and start with finding AC. And so I see, according to my angle 52 degrees, AC is my opposite. And then my 8.5 is my adjacent, and that's because it's not my hypotenuse. I know my hypotenuse is across from my right angle. And so the trig ratio that uses adjacent over hypotenuse is the TOA in my SOHCAHTOA, and so that's tangent. And so I have that tangent of 52 is equal to my opposite, which is AC, over my adjacent, which is 8.5. And so I have multiplying 8.5 on both sides, 8.5 times tangent of 52 is equal to AC. And so heading over to Desmos, I have 8.5 times tangent of 52. And rounding to the nearest tenth, I get that that is approximately 10.9. Okay, and now working again with angle B in this 52 degrees, I need to find the measure of angle AB. And so I know angle AB, or side length of AB, is my hypotenuse. And for this, I want to make sure I'm still sticking with my 8.5 over here, because that is a for sure measure. AC was an approximation, so I want to make sure I use my 8.5, which is still my adjacent. So go ahead and pause the video. I want you to finish finding side length AB. Remember, think through which trig ratio uses adjacent and hypotenuse, and solve from there. When you think you have it, go ahead and press play. So when you were solving this, you should have found that you're going to be using cosine. So you should have had cosine of 52 is equal to 8.5 over AB. And then solving that, since AB is in the denominator, it looks a little different than our previous one. You get that AB is equal to 8.5 divided by cosine of 52. And so when I come over here, I have 8.5 divided by cosine of 52. And I get that this side length is approximately 13.8. So we found our two missing side lengths. Now we just need to find our missing angle measure. Again, I know that angle A and angle B are complementary since this is a right triangle. So that means that the measure of angle A is equal to 90 minus the measure of angle B. Well, measure of angle B is 52, so I have 90 minus 52. And so I get that the measure of angle A is equal to 38 degrees.